Today we're going to be finding the maximum value of an array. So what is our challenge? We're going to be given a list of numbers. We're going to build a list of 2-digit numbers, nothing too big, nothing too small, about 10 of them. And what is our goal? Our goal is to find the maximum value on this array. We're going to consider how a human would approach this problem, and also how a computer would approach this problem, or more specifically, how we could teach the computer or program the computer to approach this problem, which has to be a more systematic approach. Let's first look at how a human would look at this problem. Here's the list of numbers from before. If I was looking at this list, now I'm a human, and I wanted to figure out what the largest number is, I would kind of look and see if there's a 93 right in the middle, 92 above it, there's a 90 below there, everything else is in the 60s, 70s, 40s. Looks like 93 is the biggest number. So we just give a general scan of our list, and we kind of look for the biggest number and we see what it is. And this works really great as a human being looking at a relatively small list of numbers. But what if the list is huge? Look at that list. I know I would not be too interested in trying to find the largest number in that list. Looks like it would be pretty hard, pretty tedious. You'd have to go through piece by piece. It's even hard to tell where one number begins and the other number ends. And there's a whole lot of numbers on there. So this list is way too big to use the previous approach, where you just kind of look at the whole and just generically figure out what the largest number is without having any plan to it. So we really need to come up with something more systematic to handle large lists. So let's look at the systematic approach. We're going to start at the beginning of the list. The first term will temporarily be the largest value. We're going to traverse the list one by one. So we're going to go through item by item every element of the list. If we find a value that is higher than the previous high value, we're going to remember that number. That's going to be the new temporary maximum. And when we finish going through the entire list, we've completed our traverse, the number that we're remembering will be the largest value on the whole list. This is a great approach for humans for large or small lists. Works for large lists is where you have to use it, or a small list you could use it, but it's not necessarily something you have to do. But for a computer, it's absolutely necessary to use this algorithm or this approach to teaching the computer or coding the computer to find the highest value. So let's check out the algorithm in action. How does it actually work? Here's a new list of numbers, relatively short, and we want to go through and systematically find the highest value on the list. So initially, starting at index 0, the highest value is going to be 45 because it's the only number on the list. So we go to the next value. Is 33 bigger than 45? It isn't, so 45 is still our maximum value. Is 58 bigger than 45? Yes, it is. So we're going to remember 58. Forget about the 45. 58 is our new highest value. We then go to 25. Is 25 higher than 58? No, so we're going to keep remembering 58. Is 61 greater than 58? Yes, it is. So we're going to remember 61. Is 36 bigger than 61? No, it's not. So we're going to keep the 61. And finally, is 45 greater than 61? No, it isn't. So we've reached the end of the list, and 61 is our maximum so far, but we've reached the end. There's no other numbers to check. So what can we conclude? That the maximum value on the list is 61. Let's look how we would code this in Java. We're going to have a list of integers called numList. And we're going to assume that it's non-empty, so there is at least one value on this array. We're going to set the maximum to be numList sub 0, the 0th number on the list. Then we're going to set up a loop. We're going to go from 1 to the end of the list, numList.length, and we're going to check if numList sub I is greater than max. So we've found a value that is greater than the max. We're going to remember that value by setting max equal to numList sub I. And then finally, when we've gone through the entire list, we've traversed the whole array, we will print out what that maximum value is, so the user would see what that value is. we always want to consider, did we solve a problem that would only work for some arrays, or is it going to work for all arrays, these arrays of integers? Will this work on small lists and large lists? Well, let's refresh our memory with the code. So this was the code that we had written previously. And since all of our looping is done in terms of numList.length, that is going to be a number inherent to the list, and it works for large lengths, so there could be 1,000,000 values, or there could be 5 values, or anywhere in the middle. So what we can see here is that regardless of the size, this process or this algorithm is going to work. So is the problem size dependent, or is this algorithm size dependent? Definitely not. So we've reached our goal of coming up with a systematic approach to finding the maximum value in a list. This algorithm is really just the tip of the iceberg. What else could we do with this? Could we adjust the code to, instead of finding the largest value, could we find the smallest value of the array? Could we adjust the code to find, instead of the largest number, but the longest string in an array of strings? Could we adjust the code to work in terms of alphabetizing? Could we find the first string alphabetically in an array of strings? Can we use the underlying concepts in this systematic approach to take it to the next level and put an array of integers in increasing or decreasing order? Or could we put an array of strings in alphabetical order? These are all great challenges and great questions that we will consider in future lessons.